Hi everyone, welcome back to my AP Calculus class. I will teach slope field today. So, I never heard about the slope field before. It's not easy to explain what slope field is. That's why I just explain about the slope field as I solve example 1, 2, 3 today. Okay, let's start. Example 1 gave you differential equation dy over dx equals y. Okay, and then I will draw slope field. Okay, directly draw slope field first. I'm gonna draw xy coordinate, and then the point is 0, 1, 2, 3, 4, and then 1, then -1, -1, 2, 3. Okay. What about x equals 0, y equals 1, 0, 1. Where is that point? That point is here, right? That point all the pairs 0, 1. What is the slope of tangent line to the curve, to the graph of this differential equation? dy over dx is given. That is the slope of tangent line. The derivative is y. That means the x coordinate never affects tangent line's slope. If at 0, 1, the y coordinate is 1, plug in 1 for this y, that means what? dy over dx is 1, means slope of a tangent line is 1. So I'm going to draw that. I don't know where it is, what shape is that original function graph, but I know at 0, 1, the tangent line, the slope should be 1. So I'm going to very tiny slope line like this. That tiny line looks like 1. What about 1, 1, this point, 1, 1? At 1, 1, x coordinate doesn't matter because dy over dx doesn't increase x, it is just y. So at 1, 1, dy over dx is 1 again. So 1, 2, 1, 3, 1, 4, 1, even -1, 1, 1, all these points, the slope of tangent line is 1. So all the same slope, right? What about if y equals 2, like 0, 2, 1, 2, which point? 0, 2 is here, 1, 2 is here, 2, 2 is here. All those points, the slope is a little higher than 1, like 2, right? That slope supposed to be 2. Even though y is -1, if y is -1, slope is -1, something like that. -1, -1. That tiny line just looks like a -1, right? Yes. Anyway, if you keep drawing every single these points, okay, every single point, draw the tiny tangent lines using slope. Okay, just to show that tiny line slope, okay, using that given differential equation. If we keep drawing these many tiny lines, I'm going to show you what is a result, okay? Let me see. Let's go. If we draw all this is the graph, right? If x equals y equals 1, every single this is 1, is y is 1, every single the tiny line, this lines, that tangent line slope looks like 1. If y is 2, that every single this line, tiny line slope looks like 2. At y equals 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, same thing. X value doesn't matter. Every single that slope looks like 3. And what about negative? At the negative, y equals -1, that slope is negative, slope like that. We already draw before, right? Something like this. If y is -2, x value doesn't matter because dy over dx given, like just y. So x value doesn't matter. If y is -2, that slope is -2, right? Slope of tangent line is -2. Why we draw this? In this case, we can find the original function. Okay, by separation. I explained it already in the last video. Okay, let me try to find that solution of this differential equation now. I'm gonna separate like this. 1 over y dy is equal to dx. 1 times dx, that means, and then put the integral notation both sides. Integral of 1 over y is ln y is equal to x plus c. So y equals e to the x plus c. That means c times e to the x. Okay, this is original function y equals c times e to the x. This is original function we found from that differential equation. Okay, so why we draw it? Why we draw a slope field? In this case, we can draw this graph if we know the c. We know what is the value of c. If we know the value of c, we can draw that graph directly, right? But sometimes you cannot. It's not easy for us to find original function equation using differential equation. Some function is very hard to find in integral, right? Okay. In this case, just draw. If you draw slope field, you can literally guess the original function graph shape. Just suppose if c is 1, that means when x equals 0, y is 1. So 0, 1, this point, right? The function graph should pass it through 0, 1. If c is 1, I don't know what is c in this case, but if c equals 1, the original function graph y equals e to the x. Suppose you don't know what shape is the graph, but just follow that lines. It looks like this. The graph looks like shape looks like past the 0, 1. If c is 1, and then the tangent lines slope is greater, so something like this. That makes sense? Yeah. That's why there's tiny tangent line over here. That makes sense. Looks like this. So the graph, just following that, connect those tiny lines shape. Think about each tiny line represent tangent line at that point. And then think about that. As you think about that, just following that shape of the tiny lines. Okay, this graph is exactly this graph form, right? Y equals e to the x graph, it looks like that. It is exponential function. What about c equals 2? If c equals 2, when x is 0, y value is 2. That means 0, 2 is here. This point, right? Pass it through that point and keep following the shape of tiny tangent line. Maybe it looks like this. So if you use slope field, we can guess, okay, the shape of original function. But that original function is kind of different location, depends on what is c. Okay, let's try solve the next problem to understand more about slope field. Example 2. The slope field for the dy over dx equals 1 over x. Okay, there is no y now. There is just x. That means y coordinate, y value doesn't affect the slope of tangent line. dy over dx derivative function, which means slope of tangent line. So y value doesn't matter. It totally depends on x value, right? If x equals 1, dy over dx is 1. So x is 1. It is 0, 3 by 0, 3. I mean 0 here, 3 here. 1 is about here, 2 is about here. 1 and 2. Okay, so what about x equals 1? At x equals 1, every single line's slope should be 1. That's why it looks like that. That slope is already given. And then that curve passes through 105. So pass it through this point. So pass it through that point and then keep following that tiny tangent line. Looks like this. Pass it this point and then go. Looks like that, right? Okay, it's not perfect, it's literally ugly, but anyway, okay, looks like that, right? Because that tiny slope line kind of looks like going parallel to horizontal line if x is bigger, and then that slope is what? Smaller, right? If x is 1, tangent line slope is 1, but if x equals to 1/2, x equals 3, 1/3, right? If x equals 100, 1 over 100, almost 0, right? So, like concave down. That makes sense, right? Anyway, this is a line. So I can solve this equation. Okay, what about dy equals 1 over x dx? That means 1 dy, put the integral. I'm solving differential equation given by separation. So it's y equals ln x plus c. I don't know what is c. If c is 0, if c equals 0, that is y equals ln x. The ln x graph looks like that. Yep, same shape, but that x-intercept is 1. But in this case, it's not 1. So you can find the x even, because y equals ln x plus c, and then that graph passes through 1 and 0.5, so 0.5 equals ln 1 plus c. c is 0.5. That means what? This x-intercept is 0.5. Got it, right? So general solution for the equation is this. But if that passes through this point, what is the equation? Y equals ln x plus 0.c. Or 0.5, sorry. C is 0.5. Got it, right? Let's go to the next problem. Next example 3. I solve just first two problem only, okay? Because I solve A and B only. If you know how to solve A and B, C and D is kind of same kind of things. So solve A first, okay? A first. Find that slope field. Derivative y prime. Y prime means the y over the same thing, right? That is cosine x. So which slope field represents that differential equation? Okay. Okay. What about start from very easy stuff? If x equals 0, that means that dy over dx is cosine 0, which is 1. So when x equals 0, y value doesn't matter because that differential equation doesn't increase y. That slope should be 1. So which graph that slope field, yeah, that tiny tangent line's slope is 1 when x equals 0. X equals 0 means what? 0, 1, 0, 2, and on the y-axis, right? On the y-axis. So this figure is not answered. First figure is not answered because the figure slope at x equals 0 is 0. Okay, in that graph, slope of tangent line at x equals 0 is 0. It has horizontal tangent line, right? So the slope is not 1. The slope should be 1. So which graph? Let me see. I got it. This graph. This graph is the answer. Why? I told you dy over dx equals cosine x. So when x equal to 0, the slope should be 1 because cosine 0. At x equals 0 here, the slope is 1. That looks like 1. Only positive. What about previous figure? That is a negative 1, looks like, right? Negative or negative 2. It's a negative slope. It is a positive slope. So only possible answer is N9-3C. That's the answer for A. That makes sense, right? So let's go back there to find that B. B says what? dy over dx is equal to 2x. dy over dx is equal to 2x. If x equals 0, slope of tangent line should be 0. 2 times 0 is 0. If x equals 1, slope is 2. It is negative 2 to 2, so it's negative 2, negative 1, 0. It is 2. This point, this looks like 1. At x equals 1, slope must be 2. Yes, it looks like 2. that tangent line slope looks like positive number, at least bigger than positive 1. What about at x equals 0? Yes, slope is 0. That's right. What about x equals negative 1? If x is negative 1, 2 times negative 1, slope must be negative 2. Check. Negative 1 is here. Yes, that slope looks like negative 2. It's going down. That makes sense, right? So, yeah, first figure is the answer of B. We can use, you can solve that slope, differential equation to find that graph. Looks like dy over dx is 2x, so dy equals 2x dx. Then put the integral to check the answers, just check answers. It is y, integral 1 dy is y equals integral of 2x x squared plus c, right? You go through 0, 0, that means it's equals 0. So y equals x squared, that shape is this, exactly, right? You can use it, you can solve, okay, differential equation to check answers, but sometimes you don't have to solve it. Sometimes you cannot solve that equation in AP exam, but just you can guess it, the slope field. If you know slope field, you can find which differential equation represent that slope field. Just plug in numbers. It's not hard at all. Okay, I'm done today. I just explained about slope field. Okay, thank you so much for watching my video. Please click notification and then subscribe and like. It helped me a lot. Thank you again. Bye-bye.